All right, so today we're going to be talking about congruent figures. So before we start, we have to know what the word congruent means. So if two figures are congruent, that means they're exactly the same size and same shape. So if I said two angles are congruent, that means they have the exact same degree measure, because that's how we measure angles. If I say two sides of a shape are congruent, that means the two sides have the same length. So over here, when it says have congruent corresponding parts, so corresponding or matching sides are congruent, corresponding or matching. So when I say corresponding, I'm talking about the matching side. So this is the definition of congruent. So go ahead and write that in there. So what that's saying is that, like when I look at all these congruent shapes over here, this side is congruent with this side because it gets flipped over or reflected. It's also congruent to this side and then this side. So these are all rotated or reflected, which is rigid motion. So if I go over to GeoGebra over here, I started with triangle ABD right there. I rotated it 45 degrees. And when I rotated it, all it did was spin it. It did not change the size or the shape of the triangle. So these two triangles that we have here are both congruent to each other because I didn't change the shape or size. So in example 1, it tells us that triangle ABC is congruent to triangle PQR. So that's how we read these things. Then we got to list the congruent parts. Well, they kind of help us out here. So A and P are the two letters that come first. So A and P are matching. So that means angle A has to be congruent to angle P. And then the second letter, B and Q. So that means angle B has to be congruent to angle Q. And then finally third, angle C has to be congruent to angle R. So now with the side lengths, it's pretty much the same thing, except to label a side like AB right here. So AB, we need two letters. AB are the first two letters, and then PQ are the first two letters. So that means those two sides are corresponding or matching. So they have to be congruent. So side AB is congruent to side PQ. And by the way, to make a congruent symbol, you do the equal sign and then a little squiggly line above it. That's how you do the congruent sign. Then the second two letters, BC, has to be congruent to the second two letters over here, so QR. And then finally the first and the third, the one we haven't used yet, AC, has to be congruent to PR. Oops. So those are our corresponding sides and corresponding angles for example 1. Example 2 is kind of similar. So this time we have two congruent triangles. We have to name the two triangles in a congruent statement. So we're going to name a triangle by drawing a triangle and then putting the three letters. So the first letter I'm going to use is the one that has this one arc. So that has that angle E has that one little arc. The matching side, or the matching angle, excuse me, angle S also has one little arc. So I know that E and S are corresponding to each other, and since the two triangles are congruent, those two angles have to be congruent. So angle E is the first one I'm going to use. Angle D has the two little arcs right there. So I got to find the angle of the triangle that has two little arcs on the other one, which would be angle R. And then finally angle F has three little arcs, and the angle T also has three little arcs. So angle F and angle T are matching up. So E and S, so D is the next one, and then F. So the first thing I'm doing is I'm just naming the first triangle. So it has angle E, D, F. It doesn't really matter the order of the first one that you do, but when you write the second one, you have to make sure that they all match up. So E matches up with S. So since I wrote E first, I'm going to write S first. R and D match up. Since I wrote D second, I have to write R second. And then finally F and T, so I'd write T third. So that's how you draw that's how you write a congruent statement for two congruent triangles. Go ahead and pause the video and see if you can do example 3 without my help. So for example 3, it's pretty much the same thing. It doesn't really matter which one you start with on the pentagons here. I'll start with the very top, so X. And I'll just go down. So Y, Z, V, W is congruent to J, K, L, M, N. So again, the first one, it doesn't matter the order that you do it in. The second one is the one that matters. So you just have to make sure that X and J are lined up together. Those are the two, or those are the two angles with two arcs. So those have to be matching up. And then I just go in clockwise order. So make sure you do the same on the other one. So X, Y, Z, V, W, and then J, K, L, M, N. On the next page, for example 4, they tell us that NPLM is congruent to EFGH. So we got to solve for X and Y. Well, the first thing I notice, N and E are the first two letters that they listed. So that means those two have to be congruent. So angle N and angle E have to be congruent or the same. So if those two angles are congruent, then I could say that 72, since it's 72 degrees, has to be equal to 7y plus 9. So since I'm supposed to solve for x and y in this one, I can solve for y right here by subtracting 9 on both sides. So I get 63 equals 7y divided by 7. So y equals 9. And then I got to solve for x. So here's where x is right here, this side length. So I need to figure out which side length on the other shape, on this shape over here, is congruent to GH. Well, if I look, GH are the last two letters. So LM are the last two letters on the other one. So that means LM has to be congruent to GH. So those two are congruent. So I can say 2x minus 3 equals 8. So add 3 to both sides. So 2x is equal to 11 divided by 2. I get x equals 11 over 2, or 5.5. All right, moving on. So the third angles theorem just says that if we know two angles in a triangle are congruent, so let's say A and D are congruent and then B and E are congruent. Since we know all triangles add up to 180 degrees, this third angle has to also be congruent. So if the first two are congruent to each other, A is congruent to D, B is congruent to E, then C and F have to also be congruent. So that's what the third angles theorem is saying. So we're going to use that in example 5. Oops. So find the value of x. Well, we know that 65, or L, I should say, is congruent to S, so this has to be 65. N is congruent to R, so this has to be 55. So again, we always know that triangles add up to 180 degrees. So to figure out what angle M is here, I could do 55 plus 65 plus M equals 180. So combine these and I get 120. So M has to equal 60. So this is 60 degrees. So since we know that M and T are congruent, then I can say that 2x plus 30 is equal to 60. So just solve for x and we get x equals 15. Kind of messed up my circle there. Hopefully you can see it. And then finally, example 6. So we got to prove that the two triangles are congruent. They already tell us that all the sides are congruent. So those two sides are congruent. These two sides are congruent. And then these two sides are congruent. So we know that this angle and this angle are congruent. So we got two lines crossing each other right here. So two lines crossing each other, the opposite angles are always congruent because they're vertical angles. So we know that those two angles are congruent. Since we know that angle P is congruent to angle N, and then RQP is congruent to MQN, we know that the third angle, let's use green, has to be congruent because of the third angles theorem that we just talked about up here. So if you wanted to write a congruent statement, you could say triangle RPQ is congruent to triangle MNQ. And that's it.